finally, let's do one. This one will be similar to 2.119. If you haven't tried 2.119, I want you to try it first. Okay, I want you to try it first. But here's what I'm going to do. Okay, I'm going to do something similar to it. 2.119. Well, so let's say we roll two balanced dice repeatedly, and I'll roll the 2 and see what I get. I'll roll the 2 dice and see what I get. I'll roll the 2 dice and see what I get. Okay, what is the probability that we get a sum of 2 before we get a sum of 3? Okay, that's what we want to know. See, I'm going to roll and I'll get a certain sum. I might see a sum of 7. The next time maybe I'll see a sum of 5. And the next time maybe I'll see a sum of 12, right? What are the possible sums? You could have a sum of 2, a sum of 3, a sum of 4, all the way up to a sum of 12. What's the chance that if you do this repeatedly that you get a sum of 2 before you get a sum of 3? Well, here's what I'm going to do. I'm going to say, let's let f sub k, be the event that you get first 2 on the kth toss and all k minus 1 previous tosses. Are not 3. Okay? Does that make sense? So then, so for example, F4, this is the event that you see not 2, not 3, right? You see not 2, not 3, not 2, not 3, and then here you see a 2. You see a 2 for the first time on the 4th toss, but you don't see a 2 or 3 anytime here. Okay? So, note then that I can write the probability of fk by itself as the probability that none of the first k minus 1 tosses are 2 or 3, and the kth toss is a 2. Now, by independence, these are independent tosses, right? So then, shouldn't that just be, let's see, what's the chance that what's the chance that the first toss is not a 2 or a 3? Well, let's see, there's one way to get a 2, and two ways to get a sum of 3, right? 1, 2, or 2, 1. So that's 1, 2, 3 ways to get a sum of 2 or 3. 3 ways. So the chance that the first one is not a 2 or 3, 1 minus 3 out of 36. Okay? And I'm looking for that to happen the first k minus 1 times. Okay? This is by independence. By independence. Okay. And now let's see. And the kth toss is a 2. What's the chance that the kth toss is a 2? Well, there's one way to get a 2 out of the 36 ways. Okay. All right. So this would be the probability of f sub k. But what I'm really after, though, in fact, let me call this event the event A. That is the event that you get a sum of 2 before you witness a sum of 3. Well, can't I write the event A then as the union? The event A is the union of those fk's. K goes from 1 to infinity, right? That is, I'm going to see a 2 before I see a sum of 3 if and only if I see the first 2 on the first toss, or I see the first 2 on the second toss with no 3's before it, or I see the first 2 on the third toss with no 3's before it, and so forth and so on. Okay, but if you think about it carefully, these are all actually disjoint events. These are disjoint events. So this is by axiom 3. I can write this as an infinite sum. Okay. And now I already know what the chance of f sub k is. Okay, so I'll just sub in there. F sub k is 1 minus 3 out of 36 raised to the k minus 1 times 1 over 36, right? So here's that infinite sum I need to deal with. It's not so bad. Actually, I can change my index here. Note that if k is 1, then this exponent is 0. And so I can actually change the indexing here and go from k equals 0 up to infinity of 1 minus 3 out of 36 raised to the kth times 1 out of 36. Now, I can pull that 1/36 out. Okay, I'll have this sum. K goes from 0 to infinity of 1 minus 3 out of 36 raised to the kth. Hey, what's, real quick, what's 1 minus 3 out of 36? 33 out of 36. Very good. Okay. And now, if you remember, or even if you don't, this sum is going to be 1 over 1 minus 33 over 36. Okay. So, does that reduce? I think it does. What's this in the bottom? That's 3 out of 36. So I get 36 out of 3. There. The answer is 1/3. How about that? 1/3. Okay.